So, Jai Hind and good morning to everyone. Today we are going to discuss creep phenomena. So, this is very important topic if you are learning this material science. So, what is the mechanism of creep? Why this creep happened? What are the various stages in creep curve? And what are the materials that can be added to avoid this creep? All these things we are going to discuss in this lecture. So, first of all, let's understand what is creep. So, the most important thing that you have to always keep in your mind, it is time dependent deformation. So, it is very important. You should remember this. It is time deformation. It is time dependent deformation under certain applied load. Means suppose you are going to apply this load on this workpiece for longer period, some deformation may happen, and that is known as creep, and sometimes also people called as a cold flow. It is the property of materials that results in progressive deformation with a constant applied load over a time. So it is very important term. Like these are the keywords that you cannot miss while defining this creep. So one thing that you have to always remember, it is time dependent deformation under certain applied load. So this is very important thing, and the load should be constant. That is another thing that you have to always keep you in mind. And duration for this kind of deformation required longer time. Means suppose in this figure, if you can observe, one brick material kind of thing is there. On that some constant load is applied over a period of time. So all these things we are going to apply here. Constant load over a long period of time we are going to apply. Then some deformation you can see it is going to happen, and that deformation is known as creep. So deformations occurs as a result of long-term exposure to high levels of stresses that are still below to the yield strength of the material. Means if you can remember, suppose this is stress strain diagram, in that this is yield point region. So maybe you are not going to touch upon that, or you are below to this yield strength, but material get some deformation due to this constant load over a longer period of time. Now just try to relate few things that I have already covered in last. Like if we are going to apply this case A, case B and case C on any material, what will happen? Under case A, what we are doing, a material is exposed to low temperature, then put into testing machine, and we are going to pull that material. Means this is a material, so we are going to pull under increasing constant load, increasing load and constant load. So it should be keyword for that, it is increasing load and constant temperature, at constant temperature. So what we are going to get under stress strain diagram, so this curve, if you can see, this kind of curve we are going to get with low temperature and short time tension. But if you consider this case B, where we are pulled under increasing load, same thing, and constant temperature, then what will be the behavior? Behavior will be like this. This is case B and this was case A. Now please notice here, if any specimen is exposed to high temperature while in the testing machine and being pulled at constant load, as we know, creep happened under constant load condition over a long period of time. Then what will be the behavior of this curve? See here, after elastic limit, after some range of elastic, it will be a straight line. So it, because of this constant load, and this is the case of creep. So this is very important. Same material, same specimen can behave differently if you are going to put constant load over a longer period of time. So this is very important that you must relate or correlate with your stress strain diagram. But when we're talking about this creep curve is plotted between strain versus time, because in definition itself we came across we have to apply constant load over a longer period of time. So here if you see, this is the actual creep curve that again I am going to draw over this. So here you just have to observe this gap. What is this gap? This is instantaneous elongation. Why this happened? Because if I am going to pull or push, means if I am going to apply any tensile load or any compressive load, certain change in their strain will happen, and after that what we are trying to make it constant. That's why here you will see very little slope is there, and after that it got fracture. So this is a creep curve, and this curve mainly divided into 3 zones or 3 sections. Section 1 is known as primary creep, where you can say lot of change in strain and other thing is happening. But if you go into secondary zone, that is longer one and the biggest zone here, and if you observe slope here, it is very less. So slope is very less here. And third zone is known as territory zone, territory creep, where suddenly because of defect, because of deformation, fracture take place. So this is the 3 stages of creep curve. So this curve basically indicates competitions between processes of strain, hardening and its recovery, you can say. So if same curve I am going to draw with different temperature. In last slide we have seen the effect of temperature, low, high temperature and low temperature and all. So if same curve I am going to draw with various like temperature zone, you can see here the range of temperature 3. This is T3 curve, suppose this is T2 and this is T1. So temperature of T3 is the highest here in this, and you can see this is little bit at the higher side. It start with little bit higher side, then here for lower, then again much lower temperature. So the starting point itself is different for them, and here the behavior is almost same. So we can conclude this: if we are dealing any material at lower temperatures, so this particular zone will be very little, and if we are dealing any material with at very high temperature, so the curve start here at very high level, and also fracture will happen at too early stage. If temperature is low, we will get more secondary zone, a very high secondary zone. What is this primary, secondary and tertiary zone? You can see here one by one. If you discuss this, stage 1 where primary creep is going to happen. So here elastic deformation is initialized, because if you observe this curve here, elastic region initializes, and elastic deformation occurs from the atomic bond stretching, and it is not permanent. Like there is a scope to for any specimen to revert back into their original position, and during primary creep also notice this deformation occurs more rapidly in the first and then slow with the time. So why this gap we are getting here? Because sudden deformation is going to happen here. So that's why it is not starting from this. Why curve is not starting from this region 0 0? Because when we are going to apply load, sudden change will happen, and after that we are going to achieve some elastic, very little elastic region, then it will enter into plastic region. Now coming to this secondary creep that happen in second stage is begins when the strain rate is stabilized and constant. So as I already discussed here, in secondary zone, in this secondary zone, you can say very less slope is there. So strain is almost constant and it is stabilized. The strain during secondary creep occurs relatively slow when compared to the first stage. So that is true. And also if you are going to compare the rate of change in this strain and other things, it will be deformation, it will be very slow as compared to first and third stage. Creep rate remains constant and relatively slow on microstructure. So this is again true for the secondary zone. Now coming to the third zone, that is tertiary zone, the final phase of creep deformation, where it is also, this zone is also little bit bigger than primary zone, but much lower than the secondary zone, and suddenly this fracture and other damage will happen during this zone. So these are the things that you should remember while explaining any creep curve. So here we are trying to relate the relation of creep curve with respect to different temperature zone. Now, if we understand general mechanism of creep, then we can avoid this also. So the general creep mechanism can be classified as a dislocation glide, then climb action, then dislocation interaction. The last one is due to diffusion flow caused by vacancies. So these are the four mechanisms under that this creep is happening. So let's understand one by one what is general mechanism of creep. First is glide, dislocation glide. So here if you see change, this is our glide plane for any material, suppose. So here it is shifting from this zone to this zone, and after that it is going out. Because of that we are getting some deformation here. So this is dislocation glide that you can avoid by just maintaining this glide plane on the center. Second one is climb. Climb can be positive climb or negative climb. Here you can see this slide plane can go up, like by default. Suppose some slip planes are there in present in any material, either they can go up or go down. So here it is shifting down and there it is shifting up. So why it is happening? Removal of row of atom decreases in the vacancy concentration. Here addition of row will happen and increase in vacancy concentration will happen here. So dislocation moving out of the original slip plane, and here you can see this is dislocation. This is a plane where we are either shifting this slip plane up or down. So climbing means either you can go up and down. Third is general mechanism, that is dislocation interaction. So here you can see dislocation can interact with each other, leading to their enlargement and hindrance of dislocation motion. So here you can see earlier behavior was like this. Some slip plane is present here and all are uniformly distributed. But here you can say there is some change. Here it was like this, but here it got some change. So the interaction is a significant factor in creep resistance. As dislocation twist and interact, they block each other motion and increasing the resistance of creep deformation. Last one is because of diffusion. So diffusion, basically what is diffusion? Movement of particles from high to low concentration. So here if you see this figure, this is dry molecules, then water, high concentration. Here moment of low concentration you can see, and here diffuse evenly. You can see all particles distributed evenly. So this kind of thing, if you are going to get, you will easily avoid this creep. And creep resistance material, suppose we have to talk about creep resistance material. So there are some bases like choosing material with high melting point, producing a large grain size, reducing the volume factors of grain boundaries. A large grain size reduces the contribution of grain boundary sliding. And third one is inducing by proper alloying material and applying heat treatment. You can easily get over this creep resistance things. So solute element you can add, like these are the various solute element that you can add if you want to get this creep resistance in your specimen. When we talk about different creep resistance material property, so there are various high temperature alloy available like nickel based, super alloy, cobalt based and iron based. So these are the various options that you can have. Refractory materials, we have tungsten, molybdenum, neodymium, like these are the high temperature points and good resistance of creep deformation they offers. If you go with ceramic matrix, then again you will get good resistance of creep under good load and constant load condition. Also some materials may be austenitic steel of grade 304, 316. They are going to offer you good creep strength and ductility. If you go with heat resistance steel, then again you will get this creep resistance things in your process. Then intermetallic compounds, you can also use certain intermetallic compounds such as iron, aluminum and nickel based intermetallics, gamma prism, like these are the some options available. Through that you can easily get creep resistance. And at the last you can see some composites are also available. In that you can also get good resistance against this creep. So this is all about creep topic. I think I have covered all the important aspects considering their definitions, creep curve, effect of temperature on creep curve, then mechanism, all four mechanism, and how we can avoid creep by introducing various materials. What is the resistance property of creep materials? So such topic I have discussed during this presentation. So this is all from my side for this topics. Thank you for listening me. Jai Hind.